Let's talk about critical values. So, a critical value is going to be really important in later chapters when we start building confidence intervals and do hypothesis testing. The notation that we use for a critical value is z sub alpha, but you'll also see in later sections that we will sometimes be interested in z sub alpha divided by 2. So the fact that we use this notation z means that a critical value is a z-score. So that means that to find z-scores, we're interested in looking at the standard normal distribution where the area under that bell-shaped curve is equal to 1, and we know that the mean is 0 and the standard deviation is 1, okay? All right, so let's talk about what alpha means. Alpha is the area to the right of the z-score, or the area to the right of z sub alpha. And critical values are z-scores that separate significantly low values from the rest of your values in the distribution, or it's a z-score that separates significantly high values from the rest of the values in the normal distribution. So this means that we're going to typically find critical values in the tails of the normal distribution because it's the tails where the area is very small, showing values that are significantly high or significantly low. So let's take a look at this first example. We want to find the critical value z sub alpha, where alpha is 0.025. So this means that we're looking for a z-score that has an area of 0.025 on the right. So I'm going to mark where approximately 0.025 is on this distribution. So I'm marking this area right here in red, okay? Has an alpha or an area of 0.025. So I want to know what is the corresponding z-score. So what is z sub 0.25? What's the z-score that corresponds with that small area on the right? There are two ways to find this critical value. You can either use the z-table or you can use your calculator. If we're using the z-table, remember that the body of the z-table gives us areas, but it gives us areas to the left of a z-score. So to use this table, I need to identify the area that is to the left of alpha. So I'll highlight that area in green. So the area to the left of alpha is this green shaded region, and we can find its value by subtracting alpha from 1. So the entire area under the curve is equal to 1. So if I take 1 and subtract alpha, I should get the area of the green region. So 1 minus 0.025 gives me an area of 0.975. So now I can go to the table and search for an area of 0.975, and hopefully you will see that that is approximately, so let's see here, up here, 0.975 corresponds with a z-score of 1.96. So this tells me that the critical value is a critical value of 1.96. It's the z-score that corresponds to an area of 0.025 on the right. Okay, now I'll show you how to do this on the calculator. So on the calculator, because we know the area, you're going to go to second vars, which will take you to the distributions, and you're going to choose option 3, which is inverse norm. And then inverse norm is going to ask you to type in the area, and again, the area to the left of that critical value. So you can either type it in as just 1 minus 0.025, which is 1 minus alpha, or if you want to, instead of typing that, you can type in 0.975, but your calculator is smart enough where it knows what 1 minus 0.025 is equal to. And then notice that for mu, you're using 0, and for sigma, you're using 1. So that's the mean and the standard deviation on the standard normal distribution. And then when you press enter, you'll see that it gives you the same critical value of 1.96.